Alright, this is Mr. Best. Welcome to combinations of functions. We'll add, subtract, multiply, and divide functions, and we'll look at compositions of functions as well. The four operations, sum, different, product, and quotient of functions. Just pay attention to the notation. You can say f plus g of x, and that's the same thing as taking two functions and adding them together. You can subtract two functions, f minus g of x. Once again, that's just subtracting two functions as well. F times g, it's just fg of x, and then f of x times g of x. Or we can do the quotient, which is division, f of x divided by g of x, or f divided by g of x. Pay attention on this one, though, because g of x cannot equal 0. These first two examples are just going through being able to add, subtract, multiply, and divide and evaluate things. I will do that on the example video. And here's another one with the product and the quotient. So we're going to go ahead and move on to compositions of functions. A composition of a function with another function. So function f with function g is written f of g of x. And there you can see that it's written two different ways. This one looks like fog, but it's f of g of x. And then the second one is written I don't know, maybe a way that seems to make a little bit more sense, where the g of x is on the inside. So you do the g of x first, and then you plug that into the function f. But either way, they're both read f of g of x. So I'm going to go through this example with you on this one. It says find f of g of x. F of x is equal to x squared. G of x is equal to x minus 3. So why do I have these pictures of what looks to be a washer and a dryer up here? Well, here's basically what a composition of a function is. You have your f of x function, which is the washing machine. You take something, clothes, put it into the washer, it washes them, and then you take them out. Okay, but the process isn't done. You now take the wet clothes, put them into the dryer, which is the g of x. The dryer does its thing, dries them off, and then when you take them out, that's kind of the final product. So you plug them into the washer, you take them out, you plug them into the dryer, and you take them out. Well, that's what a composition is. But the last picture here is f of g of x. I was able to actually find a machine apparently that does both of them, but you put them both together. So you put the clothes in, it washes them. When it's done washing them, somehow it goes in and dries them. And that's what a composition is. It takes two machines and makes one. So to find f of g of x, we're going to start with g of x. So g of x is x minus 3. So we're going to replace g of x with what it's equal to, which is x minus 3. So now it's f of x minus 3. So wherever there's an x, you're going to replace that with g of x, which is x minus 3. So in f of x, it's being x squared, or x is being squared. So now we're going to take the x minus 3, plug that in for x, and now it is being squared. So this is equal to, if you expand it out, x minus 3 times x minus 3. So that's x squared minus 6x plus 9. So this is f of g of x. And that's what we're looking for in terms of a composition. We'll also evaluate some compositions as well. Alright, the next example I'll leave for the next example video. But it just goes through another composition, but it has you evaluate some different things. And this one you'll definitely probably want to go back and take a look at, because it's going to be talking about the domain of the composition. And then the last thing I'm going to talk about in the notes is really how you take a composition and decompose it. We kind of want to undo it. All right, I'm going to give you the h of x function. So I'm going to tell you the end result is 3x minus 5 cubed. I want you to find f of g of x that equals that function. So I want you to tell me what f of x is and g of x is. So pause the video for a second and see if you can identify what those two functions are that create the h of x. So if you were able to figure it out, this is what I came up with. And if you look at this, g of x is the inside, f is the outside. So when you go to look at h of x, what's the inside? What is happening? Well, the inside is the 3x minus 5. So that's your g of x. And then what is happening to the 3x minus 5? It is being raised to the third power. So therefore, the f of x is x cubed. And so you can kind of plug that back in to see that that works. Try the second one, example B, h of x equals 1 over x minus 2 squared. And so on part B, f of x could equal 1 over x squared, and g of x could equal x minus 2. Once again, what's the inside? What is happening? The x minus 2, and then the outside is 1 over that being squared, so 1 over x squared. So that's how you can decompose composition of functions. And that is it for this section. Now let's go back and look at example 1. Given functions f of x and g of x. F of x is linear, g of x is quadratic. Find f plus g of x. So we will take f of x, which is 2x plus 1, and add g of x. And that will give us, in standard form, x squared plus 4x, and the 1's cancel. So let's make sure we write this out. We want to say f plus g of x is equal to x squared plus 4x. On part B, find f minus g of x. So we'll do the same thing. It'll be 2x plus 1, but now we will subtract, and do pay attention the order that the f and the g come in. But we are going to subtract f of x minus g of x. Because you are subtracting a quantity, everything inside gets subtracted. So I'll write it out that way so you can see what we're going to combine. And so it looks like we'll get negative x squared. The 2x's cancel. And then you have plus 2. So f minus g of x is equal to negative x squared plus 2. And so that's addition and subtraction. Now on this one, it does want us to evaluate when x is equal to negative 2. So we can plug that in. We can say f minus g of negative 2, and then you make sure you square the negative 2 and then add 2. So that would be negative 4, because negative 2 squared is positive 4, but then the negative on the outside, plus 2 is equal to negative 2. So we would want to say f minus g of negative 2 is actually equal to negative 2 also. So you got two parts there. On the next example, you're given f of x and g of x again. But on this one, we'll be finding the product and the quotient. F of x is equal to x squared, g of x is equal to x minus 3. So we're going to first do the product, and then we'll evaluate it as well. So on this one, we're going to take the f function, which is x squared, and multiplied by the g function, x minus 3. And so we can distribute, and that'll give us x cubed minus 3x squared. So that's f times g of x. And then we're going to evaluate. Now this one actually, it says f times g of x is equal to 0. So we're actually going to plug 0 in for f times g of x, which 0 is equal to x cubed minus 3x squared, and now we'll have to solve this. We can factor out an x. That'll leave us with x, actually factor out an x squared, so now that will leave us with x minus x squared times x minus 3. And so now we know x squared could equal 0, which means x is equal to 0, and x minus 3 could equal 0, so x could equal 3. So it says find x when that is equal to 0. So x, as we said, could equal 0 or 3 for that one. So we have two answers here. Here's the product, and then there's the solutions when it's equal to 0. The next one is the quotient. It just wants us to find the quotient and then evaluate when x is 3. So we will do f divided by g of x is equal to, so f of x is x squared, g of x is x minus 3. Well, the question really is, can I do anything with this? Now, some of you might think that you can cancel some x's, but remember, x squared is x times x, and x minus 3 is its own factor. It's not, x is not a factor in the denominator. So you cannot cancel any of the x's. So we are done with the quotient, except we also need to indicate that x cannot equal 3 because that would make the denominator 0. And then the next part, if you're paying attention though, it says let's now find f divided by g of 3. But from what we just said, we said x can't equal 3. So if you try to plug this in, you'll get 3 squared over 3 minus 3, which is 9 divided by 0. And we know that's undefined. So f divided by g of 3 does not exist because x equals 3 is not part of the domain. Alright, we will now move on to compositions. I did that one with you guys earlier. Let's move on to example 4. We're going to look at g of f of x, and then we're going to evaluate when x is 2 and when x is negative 4. So remember, pay attention to the order. It's g of f of x. So it's g of f of x, which is the square root of 4 minus x squared. And then wherever there's an x, you're going to replace it with the square root of 4 minus x squared. So it's x squared, so we'll do the square root of 4 minus x squared minus a. And then you evaluate. When you square a square root, those are inverses of each other, so they undo each other, cancel each other out. And now you're left with negative x squared minus 4. So g of f of x is equal to negative x squared minus 4. Now, the second part of this is to evaluate when x is 2 and x is equal to negative 4. So when x is 2, we're looking for g of f of 2 is equal to negative, and then you square the 2 minus 4. So that's negative 4 minus 4, which is negative 8. So g of f of 2 is equal to negative 8. Then we'll do x equals negative 4. So g of f of negative 4 is equal to the opposite of negative 4 squared minus 4, which is equal to negative 16 minus 4, so that'd be negative 20. So g of f of negative 4 is equal to negative 20. So we've evaluated these, and everything seems to be okay, given that, our composition is correct, negative x squared minus 4. Well, let's take a look at this a little bit more. Let's find the domain of the composition of g of f of x. So let's first look at f of x, because that's what we're going to plug into our function g of x. What is the domain of f of x equals the square root of 4 minus x squared? Well, it's not all real numbers. You can't plug in whatever you want. You can only plug in values that are between negative 2 and 2, including negative 2 and 2. If you go outside that, you're going to get the square root of a negative number. So we have some restrictions as to what we're going to plug in for the function f of x. Now, g of x is x squared minus 8. So what's the domain for g of x? Well, it's a quadratic, so you can plug in whatever you want for that domain. So then what's the domain of the composition? Well, if you can only plug in negative 2 to 2 into f of x, and then you can plug whatever you want into g of x, so there's no real restriction on the g of x, it's really what the f of x is. So the composition g of f of x has a domain of all numbers between negative 2 and 2, including negative 2 and 2. So if you look back at the two questions I asked you, one of them was x equals 2. Well, that falls in the domain, so you did get negative 8 back, which would have been correct. But on the next one, I asked you what x equals negative 4 is, and we came up what we thought was an answer of negative 20. The problem is that negative 4 is not part of the domain. If you plug in negative 4 in for f of x, so if you say f of x equals the square root of 4 minus negative 4 squared, what happens? That's the square root of 4 minus 16. So we have the square root of a negative number, which is not part of the domain. So even though the square root's being squared and those undo each other, this is not a real number. So therefore, it cannot be part of the domain. So at x equals -4, this actually does not exist. So g of f of -4 is not -20. It does not exist because -4 is not part of the domain. And so you really need to pay attention when you're finding the domain of a composition or evaluating a composition and making sure whatever that domain is, that any value that I ask to evaluate, that is part of that domain.